In this video, we're going to learn how to graph exponential functions. We started this in class and we're just going to continue on with this. So your objectives is that you can graph an exponential function. You can identify asymptotes, which is one of our big vocab words for exponential, domain and range of an exponential function, and then you can identify whether it's exponential growth or decay. Alright, so remember from the activity in class, we have exponential growth or exponential decay. So an exponential growth looks something like this, where it kind of bottoms out over here, but it keeps growing as you go left or right. Or exponential decay, it's just kind of the opposite of that, like so. Now all exponential functions have an asymptote. An asymptote is just an imaginary line that the graph does not cross. So if you notice on exponential growth, there's kind of this bottom line here, and then the same with exponential decay. Let's make it in red, that it's never going to cross. So we can say that is an asymptote here, and then we also have one here. It's the bottom of the graph. They'll keep getting smaller and smaller and smaller on both ends, and they'll never cross. Again, growth goes up, decay goes down. Alright, so also in the graph of an exponential function, we have the domain. Domain are all the x values in the function. What can you put into the function? So that is your input. The range are all the y values of the function. So that is your output. And you might recall this from Unit 2 when we talked about functions. You have your in and your out. So let's take a look at an exponential graph. We're going to do a growth, but it's very similar for decay. Alright. Now recall which one is your x-axis. Your x-axis here, and we have your y-axis over here. If you look along the x-axis, and you look at all the different x values, the graph is above all the different x values. If you plot the points, or another way to think of it is if you look at all the points, you have every single x value. So the domain of an exponential function is always going to be all reals. And all reals is just a fancy way of saying every number. You can plug in any real number, and real numbers are just like 1, 2, 3.5, decimals, negative numbers, things like that. I can plug those in for values of x, and I can get an output. Now your range, which is your y, so let's change colors here. So now we're looking up and down. Well, notice, since we have an asymptote here, from here down, there is no graph. There is no graph here. Well, that means my range is only from that asymptote and up. So say this line is at 1. So my range would be y has to be greater than 1. It never crosses the 1 value. Alright. So again, to review, domain is always going to be all reals. You can plug in every number. However, your range is going to be specific, and then this is going to be your asymptote. Okay. It's always going to be greater than some number. So let's practice graphing a few exponential functions. There's no one or specific pattern you can follow with exponential functions for the most part. So we are going to use a table of values. In the table of values, you pick the x. So I'm going to plug in 0, 1, 2, and 3. If you give me 4 points, that is good. Alright, so you're going to plug in 0 in for your x. So f of x is just another way of saying it's a function, but it's really just y. So first I have y equals 3 times 2 to the 0 power. And feel free to use your calculator, but order operations, 2 to the 0 is 1. 3 times 1 is 3. Then I'm going to do my next one. y equals 3. 2 to the first, that's 2. 2 to the first is 2. I always do my exponents and then multiplication, which is 6. We'll do the next one over here. Y equals 3 times 2 squared. 2 squared is 4. 3 times 4 is 12. Alright. And then y equals 3. We're going to do 3 times 2 cubed is 8. 3 times 8 is 24. So notice the numbers jump up big really fast. So we have 0, 3, 1, 6, and then we have 2, 24. Alright, so my graph, or 2, 12, should be somewhere up here. So I have this so far. But notice I kind of don't know what's going to happen over here. So I probably should pick some more values. So I'm going to plug in negative 1. 3 equal 3 times 2 to the negative 1. To the negative 1 is 1/2. This comes out to be 1.5. So I have... Still don't quite have a clear view what this graph is going to look like. So I'm going to plug in another one, negative 2. And sometimes you're just going to have to keep plugging in a lot until you get a clear picture. You're just going to have to do more work than you expected. So 2 to the negative 2, that's 1/4 times 3. And again, you can just use your calculator and you get 0.75. And it keeps going, and notice it keeps getting smaller and smaller. You can plug in negative 3. When you plug in negative 3, we get 1/8 gets 3/8, which I believe is 0.375. Alright, so it keeps getting smaller and smaller. Notice it's kind of approaching something. It's getting smaller and smaller to 0, but it never crosses 0. Alright. So the domain, remember, domain is always all reals. Domain is always all reals for exponential functions. We did that on the previous slide. The range, notice I'm going from here up on the y. So my range is y is greater than 0. My graph never touches 0. And then the asymptote, the imaginary boundary line, is at 0. It's intersecting the y-axis, so the equation is y equals 0. Alright, so let's do another one. Now we're taking 1/3 x plus 1. So we're going to do a table of values. And this time let's start with some negatives. We'll start with negative 2. We'll go negative 1. We'll do 0, 1, and 2. And hopefully that kind of gives us a clear picture of what we want. So kind of off to the side, I go 1/3, negative 2 plus 1, negative 2. That's negative 1. This actually comes out to be 3. I'm not going to kind of go through the calculations because really it's just calculating it in your calculator. 1/3 to the negative 1 plus 1, that is 0. That's going to be 1. So I have negative 2, 3, negative 1, 1. Plug in 0, 1/3, 0 plus 1. It's 1/3 to the, sorry, my pen is not doing a very good job of writing. That's 1/3 and 1, so that's just 1/3. Alright, so we have that right here. So very close. And then 1/3 to the 1 plus 1. That's 1/3 squared, which is 1/9. Or you can get the decimal. Again, it's very small. Alright, let's do one more. 1/3 to the 2 plus 1. And that actually equals 1/27. So again, just plugging in values for x and figuring out the y. So again, I'm getting even closer to, you can kind of see the shape of the graph. It's going to look like this. And notice, it's never going to cross the x-axis. So my domain is always going to be all reals. I can plug in any value of x. My y, again, notice it going from here up. So it's y is greater than 0. And it's not always going to be greater than 0. I know the last two examples are like that. And then your asymptote is the x-axis. So the equation is y equals 0. Alright, one last one, and we'll try to do it as quickly as we can. Do your table of values. Go -2, -1, 0, 1, and 2. Alright, plugging in -2, so go 3 times 2 to the -2 minus 4 plus 2. Alright, so 2 to the -6. This one I think we actually need to grab the calculator for. And you know what? This calculator doesn't even let us use exponents. 2 to the -6. You can do this with your calculator, and then you take it times 3 plus 2. This comes out to be 2.05. And we can do the same thing for -1. We go 3 times 2 to the -1 minus 4 plus 2. Times 3 plus 2. This becomes 2.09. And we do the 0. 3 times 2, 0 minus 4 plus 2. So it ends up being 2 to the -4. Take that times 3, add 2. 2 to the -4. Sorry, my calculator messed up. And we get 2.19. And then we go plug in 1, so it ends up being 2 to the -3 times 3 plus 2 equals 2.38. I'm just rounding to 2 decimal places, or a little more. And then we plug in 2, so 2 to the -2 comes out to be, because 2 minus 4 times 3 plus 2, 2.75. Alright, so plotting these points, get one here. They're all kind of in the 2 range, so they don't grow very fast. And what the graph ends up being, you can kind of sketch it out, something like this. Alright, so notice, you can kind of eye it, that your asymptote. Oh, I just realized I plotted this wrong. Sorry. Some of you guys are like, you're doing it wrong. Alright, so it should be here. Keeps growing. So then, your asymptote is right here. There's always a bottom to your graph. Domain is always all reals. Your range, now this time we're above 2, so y is greater than 2. And your asymptote is y equals 2. Alright, so looking at this is exponential growth because it goes up, versus the last one is exponential decay because it is going down from left to right. Alright, so that is it for the video. Remember, exponential growth goes up, exponential decay goes down. You have your domain, which remember is always all reals. Your range, which is going to be y is greater than something, whatever the bottom line is. And then your asymptote, which is going to be the equation y equals some number. Reminder to reflection so you get credit for watching this video.